We make use of product rule of differential calculus when we are told to find the derivative of a function that has two parts, and these two parts are multiplying each other. Probably you have not watched my video on how to find the derivative of a function using the product rule. You can proceed back to the channel and search for product rule of differential calculus. You are going to see how I explain in details how to use product rule to find the derivative of a function. Now let us proceed to solve this question. We have question 1, y is equals to sine x cos x. Now the first thing to do is to identify your u and v. Don't forget that if you are given to find the derivative of this function such as y is equals to uv, the first thing is to identify your u and v. The derivative of this function is given by derivative of y is equals to derivative of u multiplied by v plus the derivative of v multiplied by u. Now let's come back to our question. You can see y is equals to sine x. If you compare this question, if you compare this to this, you can see that u is equals to sine x, and v is equals to cos x. In that case, I have identified my u and v, but I see my formula that I still need the derivative of u and the derivative of v. Now, in that case, I'm going to take the derivative of u. The derivative of u, don't forget that in my previous video, I told you that if you want to find the derivative of sine x, you are going to result into cos x. So, the derivative of sine x, let me put it here, sine x will give cos x. And cos x derivative. Sine x derivative will give cos x, also will give minus sine x. So in that case, let us proceed to solve this question. I need the derivative of u and I need the derivative of v. So the derivative of u is given by sine x. Don't forget, if you differentiate sine x, we are going to get cos x. So in that case, I'm going to have cos x. And the derivative of v, which is cos x, the derivative of v is given by, if I differentiate cos x, don't forget we are going to get minus sine x. So I have minus sine x in this case. So I can proceed to substitute all these parameters into this formula. So I'm going to get y, the derivative of y is equals to, don't forget, the derivative of u. The derivative of u is what? Cos x. So I'm going to have cos x in here. Cos x. Derivative of u multiplied by v. Derivative of u is cos x. V is equals to cos x also. So I'm going to have multiplied by cos x. Let me put brackets so that you will not mix things up. So let us proceed. I have additional sign, put the additional sign. The derivative of v is minus sine x. So I'm going to have another bracket here, minus sine x multiplied by, what is u? U is sine x. So I'm going to have multiplied by sine x. So let us try to solve all the parameters inside the bracket. So I'm going to have the derivative of y is equals to cos x multiplied by cos x. That is cos square x. Cos square x plus, don't forget we still have another bracket here, minus sine x multiplied by minus sine x. That is minus sine square x. So in that case, if I open the bracket using plus multiply by minus, I'm going to have the derivative of y now becomes cos square x plus times minus, that is minus sine square x. So the derivative of y is equals to sine x cos x using the product rule of differential calculus is given by cos square x minus sine square x. Question number 2, we have y is equals to x raised to the power of 4 sine x. Don't forget our procedure. The first thing is to identify our u and v. Is that not it? That's it. So I'm going to have u, comparing this question with this, you can see that u is equals to x raised to the power of 4, and v is equals to sine x. So I've identified my u and v. In my formula, I still need the derivative of u and I need the derivative of v. So in that case, I'm going to have the derivative of u is equals to, using the power rule, I'm going to have 4x raised to the power of 3 Then the derivative of v, don't forget that when we differentiate sine x, we are going to get cos x. So the derivative of v, the derivative of sine x will give cos x. So in that case, I'm going to have cos x here. So after getting all these, the next thing is to go to my formula and substitute all these. So in that case, I'm going to have the differential of y is equals to derivative of y is equals to the derivative of u, which is 4x raised to the power of 3. I'm going to have 4x raised to the power of 3 here, multiplied by the v, derivative of u multiplied by v, and my v is equals to what? Sine x. So I'm going to have sine x in this place, sine x, the addition sign plus, I need the derivative of v also. The derivative of v is cos x, which is this cos x multiplied by u. So u is equals to x raised to the power of 4. In that case, I'm going to have here. So after getting to this point, the next thing is to just solve the bracket. You are going to have 4x squared multiply 4x raised to the power of 3 multiplied by sine x. That is 4x raised to the power of 3 sine x plus cos x multiplied by x raised to the power of 4. That is x raised to the power of 4 cos x. So in that order, you can proceed, you can leave your answer like this, and you can proceed to factorize. In that case, I want to factorize. I'm going to have what is common to both sides of the equation, that is x raised to the power of 3. So in that case, I'm going to have x raised to the power of 3 into bracket 4 sine x plus x cos x. So that is the derivative of y is equals to x raised to the power of 4 sine x. This is the derivative of this function. Now, let us proceed to the third question. We have y is equals to x raised to the power of 5 e raised to the power of 4x. To solve this question, don't forget the first thing is to identify your u and v. And if you compare this with this, the u is equals to x raised to the power of 5, u is equals to x raised to the power of 5, and v is equals to in 4x. In this case, we have an exponential function. Probably you have not watched my video on how to differentiate an exponential. You can proceed back to the channel and watch the video. Now let us proceed. The derivative of u is equals to 5x raised to the power of 4, and the derivative of v is equals to differentiate this power and then multiply this power with the function itself, that is 4e raised to the power of 4x. So after finding the derivative of u and v, the next thing is to plug in all this into this formula. So I'm going to have the derivative of y is equals to what is, I have a derivative of u is 5x raised to the power of 4, 5x raised to the power of 4, multiplied by v. V is equals to e raised to the power of x, e raised to the power of 4x rather. So in that case, I'm going to have plus this additional sign. Derivative of v is 4e raised to the power of 4x. So I'm going to have 4e raised to the power of 4x multiplied by the u itself. U is x raised to the power of 5, x raised to the power of 5. So the next thing is to solve the bracket. So derivative of y is equals to 5x raised to the power of 4 multiplied by 4x. I'm going to have 5x 5x raised to the power of 4 in 4x plus 4e raised to the power of x multiplied by x raised to the power of 5. I'm going to have x raised to the power of 5 multiplied by 4 in 4x. In that case, I can proceed to factorize, but you can leave your answer here. But at the same time, let me factorize. What is common to both sides of the equation? It is x raised to the power of 4, x raised to the power of 4. So by factorize out x raised to the power of 4, x to the power of 4 is common here. It is also common here. So I'm going to have 5x in 4x plus x multiplied by 4 in 4x. So the derivative of y is equals to x raised to the power of 5 e raised to the power of 4x is x raised to the power of 4 into bracket 5x e raised to the power of 4x plus x for e raised to the power of 4x. Now let us proceed to question number 4. We have y is equals to x raised to the power of 3 cos x. Identify u and v. U is equals to x raised to the power of 3 and v is equals to cos x. In that case, the derivative of u is equals to what? 3x raised to the power of 2, and the derivative of v is equals to what? Minus sine x. So after getting the derivative of u and v, the next thing is to plug in all these parameters into this formula. So the derivative of y becomes is equal, derivative of u, which is 3x squared multiplied by v, which is cos x, plus the derivative of v is what? Minus sine x. Let me open another bracket. Minus sine x multiplied by u. U is x raised to the power of 3. So I'm going to have here x raised to the power of 3. Now let us proceed to solve the bracket. The derivative of y is given by multiply this by this. So I'm going to have 3x squared cos x plus into bracket minus x raised to the power of 3 sine x. Derivative of y becomes 3x squared cos x plus multiplied by minus is minus. So I'm going to have minus x raised to the power of 3 sine x. Proceed to factorize or leave your answer in this form. So that is the derivative of y is equals to x raised to the power of 3 cos x. Okay, we have question number 5. Y is equals to x multiplied by e raised to the power of 2x plus 5. In this case, the first thing also is to identify our u and v. So u is equals to x and v is equals to e raised to the power of 2x plus 5. Now, for my formula, I still need the derivative of u and v. The derivative of u is equals to 1 and the derivative of v is equals to differentiate the power, that is 2x, and differentiate the power, which is 2x plus 5, that will be 2. Then multiply the power with the function itself. Probably if you have not watched my video on how to differentiate an exponential, you last. So you can proceed back to the channel and watch the video. And inside the video, I solved numerous questions on this kind of I solved numerous question on the derivative of this kind of question. So you can proceed to multiply by e raised to the power of 2x plus 5. So in this case, substitute, plug in all these parameters into this formula. I'm going to have y, derivative of y is equals to derivative of u, which is 1, multiplied by v, which is e raised to the power of 2x plus 5, and plus into bracket again. I have v, and derivative of v is 2e raised to the power of 2x plus 5 multiplied by u. What is u? U is x. So that's it. Then solving the bracket, I'm going to have derivative of y is equals to e raised to the power of 2x plus 5. E raised to the power of 2x plus 5 plus x multiplied by 2, that is 2x. So I'm going to have 2x e raised to the power of 2x plus 5. In this case, I can factorize e raised to the power of 2x plus 5 out. So I'm going to have e raised to the power of 2x plus 5 into bracket 1 plus 2x. So the derivative of 1 is equals to x e raised to the power of 2x plus 5 is e raised to the power of 2x into bracket 1 plus 2x. So that's the derivative of this question number 5. Now we have y is equals to x raised to the power of 5 multiplied by cos x. I want you to solve this and drop the answer inside the comment box. How do we take the derivative of an exponential here? Let's assume that we are given y is equals to e raised to the power of u, and we are told to find the differential form of y. Using the formula y, derivative of y is equals to, focus on the power to which the Euler's constant is raised to. The Euler's constant is raised to the power of u. Then differentiate the power. So I'm going to have the derivative become like this: differential of the power to which the Euler's constant is raised to multiplied by the function itself. What is the function? The function is y is equals to e raised to the power of u. So in that case, I'm going to have y, differential form of y is equals to u multiplied by in u. That is u differential multiplied by in u. Now let us proceed. Let's assume that we are given a function f of x is equals to 2e raised to the power of 2x. Using the same approach that we have here, we can say that since the power of Euler's constant is 2x, so I'm going to have u is equals to 2x. In my formula, I need the differential form of u. So I'm going to take the first derivative of u. The first derivative of u using the power rule is 2. So I'm going to have 2 here. After getting the derivative of u, I can proceed to use this formula. The differential form of this function f of x is equals to the differential form of u, which is ui, multiplied by the function itself, which is fx. Ui, that is the differential form of u, the first derivative of u multiplied by the function. And don't forget that the first derivative of u is 2. So I'm going to have the first derivative of fx is equals to 2 multiplied by f of x is 2 in 2x. So 2 multiplied by 2 in 2x. So in that case, I'm going to have f of x, first derivative of x is equals to 2 multiplied by 2. That is 4. So I'm going to have 4 in 2x. We have question number 1. F of x is equals to in x. Don't forget the procedure. The first thing is to focus on the power to which the Euler's constant is raised to. In that case, I'm going to be having u is equals to the power to which the Euler's constant is raised to. So I'm going to have u is equals to x. So from the formula, I need the derivative of u. So I'm going to take the derivative of u. U derivative is equals to 1. Don't forget the formula. The formula goes thus: the derivative of fx, the first derivative of fx is equals to u derivative multiplied by the function itself, which is fx. So in that case, we are going to have the first derivative of fx is equals to the derivative of u is 1. So I'm going to have 1 multiplied by what is the function? The function is what? In x. Fx is in x. So in that case, I'm going to have in x. So the first derivative of x is equals to in x. So now let us proceed to the next question. We have y is equals to in 2x. The first thing is to set u equals to the power to which the Euler's constant is raised to. So I'm going to have u is equals to 2x. And from the formula, I know that I need the derivative of u. I need the first derivative of u. So I'm going to have the first derivative of u is equals to 2 using the power rule. Probably you don't know how to solve differential equation using the power rule. You don't know how to differentiate using the power rule. You can proceed back to the channel and watch how I use the power rule to differentiate a function. So now let us proceed. We have u equals to 2x. The derivative of u is equals to 2. Now don't forget our formula. If I want to find the derivative of y, the derivative of y is equals to the derivative of u, which is the power derivative of the power to which the exponential function is raised to, multiplied by the function itself, which is y. So I have gotten the first derivative of u, that is 2, and the function is what? Y. Y is equals to e raised to the power of 2x. In that case, I can substitute both derivative of u and y. The derivative is 2 multiplied by what is y? Y is equals to in 2x. So I'm going to have in 2x in this place, in 2x. So the derivative of y is equals to 2e 2x. So that is the derivative of y is equals to e raised to the power of 2x. So in that case, I'm going to have the derivative is equals to 2e raised to the power of 2x. So let us proceed to question number 3. Okay, we have y is equals to e raised to the power of x squared plus 1. Don't forget our approach. The first thing is to set u as the power to which the exponential function is raised to. So in that case, I'm going to have u is equals to x squared plus 1. The derivative of u derivative is equals to, using the power rule to differentiate this x squared, I'm going to have 2x, and if you differentiate a constant will give 0. So in that case, the derivative of u is equals to 2x. Now the next thing is to recall that our formula is the derivative of y is equals to the derivative of the power, which is the u, multiplied by the y itself, which is the function. So in that case, the derivative of y is equals to, what is u? Derivative of u is 2x. So I'm going to have 2x multiplied by y. Y is equals to e raised to the power of s squared plus 1. In that case, I'm going to have e raised to the power of s squared plus 1. So the derivative of y is equals to 2x 2x in s squared plus 1. So that is the derivative of y is equals to e raised to the power of s squared plus 1. Now let us proceed to the next question, which is the fourth question. Y is equals to 5e raised to the power of 4s squared. What's the answer? You can drop your answer inside the comment box. I'm going to assess it. So now let's try this. Don't forget that the first thing is to set u is equals to the power to which the exponential function is raised to. In that case, I'm going to have u is equals to 4x raised to the power of 2. So we are going to take the derivative of u with respect to the independent variable, which is what, x. So I'm going to have u is equals to, the derivative of u is equals to this power multiply the coefficient. I'm going to have 8x, the power reduced by 1, that is 2 minus 1, x raised to the power of 1 is 1. So in that case, I'm going to have the derivative of u is equals to 8x. Then after getting the derivative of u, don't forget that the differential equation of y, the derivative of y is given by derivative of the power to which the exponential function is raised to, u multiplied by the function itself, which is y. In that case, don't forget that our y is equals to 5e raised to the power of 4s squared. In that case, I'm going to have the derivative of y is equals to the derivative of u is 8x multiplied by y, which is 5e raised to the power of 4x squared. 8x multiplied by 5, that is 40x. In that case, I'm having y derivative is equals to 40x multiplied by e raised to the power of 4x squared. Therefore, the derivative of y is equals to 5e raised to the power of 4x squared is 40x e raised to the power of 4x squared. Now, the fifth question we have, y is equals to e raised to the power of sine x. Don't forget, using the same approach, we have to set u equals to the power to which the exponential e is raised to. In that case, I'm going to have u is equals to sine x. And in differential calculus, if you differentiate sine x, if you differentiate sine x, sine x will give cos x. And if you differentiate cos x is equals to minus sine x. In my next video, I'm going to show you how to prove this. But add this at the back of your mind. If you differentiate sine x, you are going to get cos x. If you differentiate cos x, you are going to get minus sine x. So in that case, let's proceed back. Let's come back to our question. We have y is equals to e raised to the power of sine x. The first step is to set u as the power to which the e is raised to, which is Euler's constant. So I'm going to have u equals to sine x. Then take the derivative of u. The derivative of u is, don't forget, in differential calculus, when you differentiate sine x, you are going to get cos x. So the differential of sine x is equals to cos x. So don't in that case, I can proceed and say derivative of y is equals to derivative of u multiplied by the function y itself. So the derivative of y is equals to derivative of u is cos x. I have cos x here, cos x, cos x multiplied by, don't forget that the function y is equals to e raised to the power of sine x. So I'm going to have e raised to the power of sine x here. So the derivative of y is equals to cos x e raised to the power of sine x. So that is how to find the derivative of e raised to the power of sine x. Now let us proceed to the sixth question. We have y is equals to e raised to the power of cos x. The first thing to do is to set u to the power to which the Euler's constant is raised to. Follow the same approach, get your answer, and drop the answers in the comment box. I'm going to check it and reply. Under this, we're going to look into meaning of chain rule, the chain rule formula, when do we use chain rule of differential calculus? How to use chain rule of differential calculus and application of chain rule in trigonometry. The chain rule refers to the method of differentiation that is used in differentiating a function of a function. That is, when we have a composite function and we are told to differentiate that function. In that case, we employed the chain rule of differential calculus. A function of a function refers to a function that has a function in itself. The chain rule formula is given by the y over the x is equals to the y all over the u multiplied by the u all over the x. Now, when do we use chain rule formula? The chain rule formula is used when we are given a function that is a composite function and we are told to differentiate this function. In that case, we employ the chain rule formula. Don't forget that a function, a composite function, is a function that has another function in itself. So in that case, we make use of chain rule formula to differentiate such function. The function must be differentiable, that is, we must be able to differentiate that function. Now, the question is, how do we use the chain rule of differential calculus? Since chain rule is employed in differential calculus when we are told to differentiate a composite function, the first step is to identify the outer function and the inner function. The second step, we differentiate the outer function and the inner function. Then the third step is to multiply the derivative of the outer function with that of the derivative of the inner function. We have some example in this place. Find the derivative of the following function. Y is equals to 2x plus 4 raised to the power of 4. To solve this question, the first step is to identify the outer function and the inner function. Now in that case, I will let this is the inner function. 2x plus 4 is the inner function. So in that case, I will have let u is equals to 2x plus 4. Since I have set the inner function as u, then this function will be y will be equals to y is equals to u raised to the power of 4. So in that case, this is the inner function and this is the outer function. Now the next step is to differentiate the inner function and the outer function respectively. If I want to differentiate this function u is equals to 2x plus 4, recall from the power rule of differential calculus, the u all over the x is equals to 2. Then let us differentiate the outer function also. In that case, I will have the y all over the u is equals to 4u raised to the power of 3. So I have differentiated the outer function and the inner function. Don't forget that from chain rule formula, the y all over the x is equals to the u over the x multiplied by the y all over the u. So don't forget that the u all over the x is equals to 2. So in that case, I will substitute 2. 2 multiplied by the y over the u, which is this 4u raised to the power of 3. So I'm going to have 4u raised to the power of 3 all over the x is equals to 2 multiplied by 4u raised to the power of 3. That is 6u raised to the power of 3. So don't forget that u is equals to 2x plus 4. So therefore, the y all over the x is equals to 6 into bracket 2x plus 4, 2x plus 4 raised to the power of 3. So we have been able to find the derivative of the composite function y is equals to 2x plus 4 raised to the power of 4 using the chain rule formula. The second question we have y is equals to x squared plus 3 raised to the power of 9. The first step is to identify the inner function and the outer function. Therefore, I'm going to set u is equals to the inner function, which is x squared plus 3. X squared plus 3.
So if u is equals to x squared plus 3, then y is equals to u raised to the power of 9, because I have set u is equals to this inner function. So therefore, y, which is the alpha function, becomes u raised to the power of 9. Now the second step is to differentiate the inner function and the outer function. So I'm going to have the u all over the x is equals to 2x. And then we want to differentiate this outer function, y equals to u raised to the power of 9. The y all over the u is equals to 9u raised to the power of 8. So don't forget, from chain root formula, the y all over the x is equals to the u all over the x multiplied by the y all over the u. The y over the x is equals to, don't forget that the u over the x is equals to 2x. So I'm going to have 2x multiplied by the y over the u, which is 9u raised to the power of 8. 9u raised to the power of 8. Yes, I'm going to have the y all over the x is equals to 2x multiplied by 9 into brackets. What is u? U is equals to x squared plus 3. Instead of writing u here, I'm going to substitute it as x squared plus 3. So I'm going to have 9 into bracket x squared plus 3 raised to the power of 8. So therefore, the y all over the x is equals to 2x multiplied by 9. That is 18x. 18x into bracket x squared plus 3 raised to the power of 8. So therefore, the derivative of y is equals to x squared plus 3 raised to the power of 9 is given by 18x into bracket x squared plus 3 raised to the power of 8.
And the last question, we have y is equals to x raised to the power of 10.
To solve this question, y is equals to x raised to the power of 10, you can use the power rule of differentiation, and you can also make use of the chain rule. Now let us differentiate. Let u is equals to the inner function, which is x. Then if u is equals to x, y is equals to u raised to the power of 10. The u all over the x, don't forget, it will be 1, and the y all over the u is equals to 10u raised to the power of 9. The y all over the x is equals to the u over the x, which is 1 multiplied by the y over the u, which is 10u raised to the power of 9. That is 10u raised to the power of 9. The y all over the x is equals to 1 multiplied by 10u raised to the power of 9. That is 10u raised to the power of 9. So substitute the value of u equals to x. In that case, I'm going to have 10 into bracket x raised to the power of 9. Now let us make use of the power rule of differentiation to differentiate this function. Don't forget that if you are given y is equals to x raised to the power of 10, if we make use of the power rule, the y dx is equals to the power will multiply the coefficient, which is 1. That's why I'm going to have 10, and the power will reduce by 1. I'm going to have x raised to the power of 10 minus 1, that is 9. So have you seen, if you make use of the power rule, you are going to get the same answer if you make use of the chain rule of differential calculus. So there are some functions that it will be very hard to differentiate using the power rule of differentiation. So we make use of the chain rule of differentiation.
Now, when do we use chain rule in trigonometry? Chain rule is used in trigonometry when we want to differentiate a trigonometric function that contains another function. Example, we have find the derivative of y is equals to sine 2x.
Don't forget, the first step is to identify the outer function and the inner function. In this case, I will set u is equals to the inner function, which is 2x. So u is equals to 2x. If u is equals to 2x, then y is equals to sine u. The next step is to take the derivative of the outer function and the inner function. So the u all over the x, the u all over the x is equals to 2. And the y all over the u, don't forget, if you differentiate sine u, you are going to get cos u. So the y over the u is equals to cos u. The y all over the x is equals to the y over the u multiplied by the u all over the x. So the y all over the x is equals to the y over the u is equals to cos u. So I'm going to have cos u in this place, cos u multiplied by the u all over the x, that is 2. So the y over the x is equals to 2 cos u. Now don't forget that I have set u is equals to 2x. So therefore I'm going to substitute the y all over the x is equals to 2 cos 2x. So the derivative of y is equals to sine 2x is 2 cos 2x.
The second example, find the derivative of y is equals to tan x squared.
The first step is to identify the inner function and the outer function. In that case, I'm going to set u is equals to the inner function, which is x squared. So u is equals to x squared. If u is equals to x squared, then y will be equals to tan u. The second step is to differentiate both the inner function and the outer function. So I'm going to have the u all over the x is equals to 2x, and the y all over the u is equals to, if you differentiate tan u, you are going to get sec square u. Now the y all over the x is equals to the u over the x, which is 2x, multiplied by the y over the u, which is sec square u. Sec square u. So the y all over the x is equals to 2x. Don't forget that u is equals to x squared. So I'm going to have 2x sec square x squared. So the derivative of y is equals to tan x squared is 2x sec square x squared. Now let's proceed to the third question.
Find the derivative of y is equals to cos 2x squared plus x.
Don't forget, the first step is to identify the inner function and the outer function. So in that case, I'm going to have u is equals to 2x, which is the inner function, 2x squared plus x. So in that case, y is equals to cos u. The next thing is to differentiate the inner function and the outer function. Therefore, I'm going to have the u all over the x is equals to 4x plus 1. The y all over the u is equals to, if you differentiate cos u, you are going to get minus sine u, minus sine u. Don't forget, the y over the x is equals to the y all over the x is equals to the u over the x, which is 4x plus 1 multiplied by minus sine u. So the y.
Here are some few questions that I want you to attempt on your own. We have question 1.